Hello, everyone. Unsweetened uranium here. I hope you're all having a good day. Today, we're going to be talking about alkenes. So, last video, we were talking about alkanes. Today, we're going to be talking about alkenes. So, they're a little different than alkanes because, unlike alkanes, we now have a double bond. So, let's start with this. So, let's talk a little bit about this. All right. So you'll notice off the bat that what I've drawn here as a double bond. I have two carbons and four hydrogens. Okay. And both of my carbons are what type of hybridization? Give you a second to think about it. What's the hybridization of these two atoms? I'll give you a hint. It's not sp3, right? It's sp2. Oh, forgive me, I don't have a mouse still. So both of these are sp2. All right. So it's an unsaturated hydrocarbon. That means that it's unsaturated, means we have the ability to add hydrogen atoms onto this, right? If I wanted to, I could use some hydrogen gas, right? If I wanted to change this to an alkane, I could use some hydrogen gas, some H2, and some metal catalyst, H2, right? And then I would get the alkane, right? I get ethane, okay? So, we talked about that. Okay, we have the ability to add hydrogen. That's what's called unsaturated, right? So if you hear unsaturated, you want to think, oh, I can add hydrogens here because of this double bond. Okay, and don't worry about the mechanism for this. It's a little more complex. You're welcome to look into it, but most professors will just expect you to know this. They probably won't ask you to draw out what's happening here. So let's talk a little bit more about this, that carbon-carbon double bond, right? So it is a pi bond and a sigma bond, but it's not twice as strong, okay? So this bond energy right here of a carbon-carbon double bond is 611 kilojoules per mole, joules per mole, okay? And a carbon-carbon single bond, right? So just a carbon-carbon bond like this has 347 kilojoules per mole. So it's not twice as strong, right? It's not twice as strong. Main difference here is it's going to be more reactive, right? Because these are now in a pi bond. And this distance right here is going to be shorter than the distance here. So that's just something to think about. Um, one more thing I want to talk about are alkenes are more acidic than alkanes. I thought that was important to know. And also the solubility. So alkenes are insoluble in water. So they're not soluble in water. So if I mix those together, right? Eh, not good. We're not going to want to put in water. We're going to want to put it in a nonpolar organic solvent such as diethyl ether, like this, something like this. Okay? We're going to want to put it in a nonpolar organic solvent. All right, something to think about. So let's go back here. So we know we have sp2, right? All right, let's go back to this. Okay, so we talked about unsaturation. We talked about this double bond and why it's important to us and how it's more reactive than an alkane. Let's talk about cis versus trans. So this is a topic you will cover in organic chemistry. So this, and let's say I have this. Okay. So cis versus trans. What does it mean? Well, Essentially, it's talking about the largest priority groups that are adjacent to this double bond right here. Okay, so if we look at these groups, right, because we have our implicit hydrogens here, I can draw them in, right? Something we're gonna have to get used to. We start organic, but I'll draw them in for now. Help visualize it better. Okay, so these are hydrogens. Okay, and one of these is cis, and one of these is trans alkene. Okay, so they're also designated as E and Z. Those are their German counterparts for entgegen and zusammen. So you have E and Z. Okay, so entgegen, right? That's going to mean opposite. So trans and entgegen are the same. So E and trans are the same. Cis, zusammen, means together. So Z and cis are the same. And essentially, that same or opposite is referring to these largest groups, the highest priority, sorry, groups on this double bond right here. So if you look, I have methyl group here and a methyl group here. And if we look across this double bond, you can kind of tell they're on opposite sides. If you think about it, they're on opposite sides. If I was looking at this from above, right, they would be on opposite sides. We're looking at it on a board. So one's up here and one's down here. They're on opposite sides. And that is because unlike a single bond, which at room temperature, you know, like they rotate, they're rotating, they're turning, all this and that, double bonds are rigid. So if I form this double bond here, these two are stuck. So this molecule will be flying around. It's stuck in this position, right? This group's always going to be over here. This group's going to be here. They're on opposite sides, right? So if they're opposite, entgegen, or trans, this one would be our trans alkene. Okay, so you could see either of these. All right, most professors will use cis or trans, but be prepared, they might put E or Z on there to try to throw you off. Okay, so let's look at this one over here. Say we're looking at it from above or straight on a board, right? So this is a rigid double bond, it's not rotating, and our highest priority are methyl groups. We have a methyl group here, methyl group here. If you think about it, they're both up here, right? They're both up there, okay? They're on the same side, right? So this would be cis, okay? Or, oops, sorry, or zusammen, okay? So if you see E or Z, or cis or trans, it's referring to these largest priority groups that are on this double bond, this rigid double bond. Okay, so that's an important part of alkenes. We'll get more into depth. There's certain reactions where these are going to have a lot of importance. Okay, but for now, we're just introducing, we're getting familiar with the terms, right? So we see alkene now, right? And it's similar to the nomenclature. If you have any questions on nomenclature, you can drop in the comments. But right, so it's an alkene instead of that ane ending, right? You're going to have that ene ending. Okay. Right? So ethylene instead of ethane, right? Or propylene. Okay. So let's move on. All right. That's actually all right. Last thing for today, we're going to do an example reaction. Okay. So it's going to be the first reaction on the channel. Hope you guys are excited. Let's start with this. Our starting material. Just this simple alkene. Okay. And what I'm going to do, I'm going to add hydrobromic acid to it. Okay. That's what I'm going to do. So, what's going to happen first in this reaction? First of all, I want you to think about it and try it before I go about the reaction. All right, now I'm going to do the reaction. We're going to take these electrons in our double bond, and they're going to actually attack this hydrogen, right? Remember, our arrows always start from electrons. We're not going to start the arrow from the hydrogen. So these electrons, right, grab this proton. These electrons are now going to go into bromine. So what we're left with is this. And I want you to think about what I did wrong. I purposely made a mistake. I want to see if you can catch it. Okay, so boop, 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 boop. All right, there's a mistake here. I'll give you 5 seconds to find it. All right, what happened was, if you look here, we had 4 bonds to this carbon, correct? So we had our 2 hydrogens, we'll try and a sigma double bond. Okay. So, right, we had that. Ooh, we had hydrogen here. It's a little cramped. 1, 2, 3, 4 bonds to this carbon atom. Over here, 1, 2, 3. I still have 4 bonds to that carbon atom, right? Now let's look on the other side of the reaction arrow. Over here, 1, 2, 3, 4 bonds to this carbon atom. 1, 2. Uh-oh. I'm only seeing 3 bonds here. Carbocation right here. Which is going to help us understand what happens next. And what's going to happen next is going to take these electrons, we're going to attack the carbocation, and we're going to get, I'm not drawing in the hydrogens, but this as our product. Okay, so it's the first reaction on the channel. Hope it was exciting.